Okay, calculus, as promised, I will talk you through some homework problems. We'll start at the first section we did online, which was 9.6. Here are two examples that I think are important. It's 1D, so the last problem from the first page, which is the sum from n equals 0 to infinity of n factorial over 3n factorial using the ratio test. This is good practice for you guys to get used to dealing with the factorials and the little subtleties that will take place when you do it. So of course, use the ratio test. You use the n plus 1 term divided by the nth term. That would be n plus 1 factorial over 3 times n plus 1 factorial over n factorial over 3n factorial. Now, 3 times n plus 1 needs to be distributed to 3n plus 3. And of course, if you divide by a fraction, you multiply by the reciprocal. From there, I pair up the n terms and the 3n terms because it's going to be easier to cancel things out. N plus 1 factorial divided by n factorial, the n plus 1 factors out, and then you are left with two n factorials canceling, which is why you end up with n plus 1 here. The 3n factorial over the 3n plus 3 factorial, you've got to be careful. Imagine that n was 2. This was 6 factorial then over 6 plus 3, 9 factorial. There's actually 3 numbers that survive. 3n plus 3, 3n plus 2, and 3n plus 1 all have to be factored out for the 3 n's to match up. So what you end up with is n plus 1 from the first part, and 1 divided by those 3 numbers we just mentioned, the second part. Now if you look at n plus 1 divided by 3n plus 3, this is really just 3 times n plus 1. So the n plus 1's will cancel, and you'll just be left with the 3 here. So I separated it into 3 terms. It's 1/3 from this first part, and 1 over 3 plus 2, and 1 over 3n plus 2, and 1 over 3n plus 1. They're all multiplied together, but we can take the limit now. As n goes to infinity, this is going to be 1/3 times 0, which is 0, which will converge by the ratio test. So you do have to be careful, especially when you have numbers in front of the factorials. It's not always just that thing that survives. Sometimes there's more, so you really kind of have to understand how factorials work in order to work them. Now the second one I wanted to do, not because I think it's a hard problem, but because most of you would look at this and are more comfortable using the ratio test on this to prove that it converges, but it forces you to use the root test and come to a conclusion about something in particular. Now, for the root test, you have to take the limit of the nth root of both of these. Now, all of the root tests we did up to this point, they usually had a power of n in them. This one is different in that we have just a regular n in the numerator. So when I take the nth root of both of these, I know the denominator is 3, but I have this n to the 1 over n power that it's really kind of indeterminate, because if you take the limit as n goes to infinity on that thing, you have a infinity to the 0th power, which you don't necessarily know what the answer is. So I really wanted to do this problem just to show you what the answer is in this specific case. So in order to solve this kind of issue, this is where you do e to the ln. It's like when we proved the limit of 1 plus 1 over n to the n was e to the first power. It's kind of like that. You can take the e and ln of both things. So let's look at that. So when I take the limit as n goes to infinity of e to the ln of n to the 1 over n power, that allows me to bring the 1 over n out in front. I also can take the e out of the limit because it doesn't have any n's in it, so it's e to the limit as n goes to infinity of 1 over n times the ln of n. Now 1 over n can still be just used as division. E to the limit as n goes to infinity of ln of n over n. Now this is going to be infinity over infinity, where we use L'Hopital's. So this is equal to e to the limit as n goes to infinity. The derivative of ln of n is 1 over n. The derivative of n is 1. So it's just 1 over n divided by 1, which means it's just 1 over n. Now e to the limit as n goes to infinity of 1 over n. As n goes to infinity, 1 over n goes to 0. So this is e to the 0th power. Anything to the 0th power is 1. So what does that mean? That means the nth root of n as n goes to infinity is equal to 1. It means like the 1,000th root of 1,000, you can type 1,000 to the 1 over 1,000 power in your calculator, and it should be pretty close to 1. Therefore, if this thing is 1, then this whole thing originally has to go to 1 over 3, which is 1/3. So even though you would have used the ratio test more comfortably, even by the root test, this converges. Now for future use, you don't have to prove to me that you know n to the 1 over n power, the limit as n goes to infinity of that, is 1. You can use that if you ever encounter it on a test or anything like that in the future, but I figured it's good to prove it and show it because that one probably threw some people for a loop on the homework. Now the pages 3 and 4 were just practice of all different types from the first 6 sections, so I would just practice those, and I will do more highlights today later.